Greetings, Professor, and welcome to our video demo for assignment 2. Our group has developed a secure client-server chat application in Python using socket programming in Visual Studio and enhanced it with end-to-end encryption, chat history retrieval, and AI-assisted development. I have prepared 4 terminals with me for the demo. So there's a README file for the instructions, and these are my members. And before we get started with the codes, you should install the cryptography in your terminal so that the encryption can work. So the server.py serves as the central hub that manages connection, message routing, and group handling. So now I'll try to connect the server. As you can see, the server is now running. And next, the client is the interface for the user connecting to the server to send and receive messages. So now I'll connect a client named John. As you can see, John is connected successfully to the server and is reflected on the server terminal. Now I'll try to enter with an invalid name. I added a space in front. Let's say hi. Because there's a space in front, it's invalid. So let's say I'll enter with a valid name. And as you can see, the server is informed and the other client are aware of that Peter has joined as well. So next, I'll try to enter with a name that's already taken. Because John is already in the server, I cannot use that name. So now I'll try to enter with Stella. As you can see, all of them has connected successfully. So now I'll showcase the basic commands. So let's say for broadcast. So hi everyone. As you can see, the rest of the clients received a message from Stella. Next, I'll be demoing the private message function. So for example, I'll use John's client to send a message to Stella. Let's say Stella, hi, I'm John. How are you? So as you can see, Stella has received the private message from John. And as you can see, I have added exclamation mark and question mark. So because of the design of this regex, the server uses regex to extract the username and message and validates the recipient. So let's do some test cases. So let's say, for example, I enter an empty message. You enter an error, message cannot be empty. So let's say I try to send to someone that's not in the server. Hi David. You say that user is not found. So these are done with the function of this line in the code and this line, where they will check for the empty messages and check for if the user is actually in the server. We also have the adnames function. As you can see, adnames will list out all the users that is currently connected to the server. Now we'll test group features, creating a group, sending group messages, leaving and deleting. So let's say I'm on John's client and a group set team 1 with John and Peter. So as you can see, group team 1 is created. And then since I want to send a message using Peter's client, group send team 1 meeting at 4 p.m. It will send to all members in the group. Let's say I want to live in John's client, group live team 1. So I have left team 1 and I want to check the members of the group team 1, group members team 1. As you can see, John left, so Peter is the only one left. Let's say I want to create team 2. It will show that it's an invalid command because create is not an actual command, and it will ask prompt to use the correct command. So I can also group delete the team, group delete team 1, and as you can see, the group has been successfully deleted. So now I'll go through the additional functions that I have created. So first is the detect spam function. So this function checks if the user is sending repetitive message within a short time, which I have set 2 seconds for this. So it tracks the last message and it's time stamp for each user. So if the same message is sent again within 2 seconds, it flags it as a spam and returns true, and the message will not be sent successfully. So as you can see, if I go on John's client and I type too fast the same message, it will say stop spamming, and the other clients won't receive the spam message. So this helps prevent spam and message flooding in the chat. But if I type quickly but it's not the same message, it will allow the user to send. So let's say, hi, hello, what you are. So as you can see, it's sent very quickly but it's different message, so it's not flagged as spamming. Next additional function, I'll be talking about the encryption. So as you can see in this encryption.py, this code handles end-to-end encryption for the chat application using FurNet, a symmetric encryption method from the cryptography library. So what it does is a key management. First, it checks if a file is called secret key exists. If not, it generates a new encryption key and saves it. Then it loads the key for use in encrypting and decrypting messages. So over here, there's a function for encrypt and decrypt messages where it's used a lot. So encrypt is it will encrypt a string using the loaded key, and decrypt will decrypt the encrypted string back into readable text. Why this is important is for security, so it ensures all messages sent over the network are private. So whenever someone outside of the network tries to read the messages, if it does not have the key, it cannot read the readable text. So for simplicity, Fernet handles safe encryption with a single key, suitable for our use case. So as you can see in this server.py, many of these messaging functions have encrypt message in them, such as broadcast and send private message, and the receiver will decrypt the message so that they can read it. So the flow of this is, for example, as you can see in the John's client at the top right, he sent a few messages earlier. So all these messages are encrypted using the shared secret key, which is stored in the secret key file before it is sent over the network. The encrypted message is received by the recipient, for example, the other users Peter and Stella. So these users can decrypt the message using the same secret key. If the secret key is correct, Peter and Stella can see the original message. If the key is incorrect or missing, Peter and Stella will not be able to decrypt the message and will likely see gibberish. So this prevents anyone from outside the network to view what are the contents in this chat. The last additional function I'll be talking about is the encrypted chat history retrieval function. So this function log message will record all message and encrypt it in the log file for history. And then this next function is the function for send chat history. So when the user type add history, it will decrypt all messages in the file if they have the correct secret key. It does so by decrypting each line and to turn it back into readable text. So I have opened up the chat history log. As you can see, these are all the encrypted messages that are sent earlier. So whenever they add history, so it will read all these messages and decrypt it correctly if they have the correct secret key. So let's say John wants to read the history. As you can see, this is the chat history from earlier. It started with Stella saying hi everyone, and these are the rest of the history. And finally, we have the quit function, which allows the user to disconnect. So quit. So as you can see, the server and the other clients are informed that the John has disconnected from the server. So let's say Peter wants to leave too. He will quit, and then he will inform the rest, and also finally Stella that everyone quit successfully.